See, in California, there's an actual sun that shines in the sky and makes things warm. But here in the state of Washington, that's not really how they do it. So I'm getting used to that. Can I summate the primary goals? No, I mean, I'm not. It's just complicated. And I really put more of my time into building the language than I do into documenting it right now. In fact, there's almost no documentation. The reason I do these streams is because they're sort of documentation, and they're also bounded in time. Like I sit down to do one, and it takes an hour or 2 hours or whatever, but then I can go back to working on the real work. At some point when the design is finalized, then we'll probably document it, but that'll be in a while because things are still changing. Things are still changing. Oh, okay. What do I think of semi-implicit context passing to a function? What I mean is that you can call a function that implies the context of the caller. I don't know what you mean by implies the context of the caller. Do you mean like dynamic scope in Lisp? Or something else? I'm not sure. You'll have to ask that more specifically. What is the sanest graphics API that I have used? Probably DirectX 9. I haven't really done much in DirectX 10, 11, or 12, so I can't speak to that. DirectX 9 is way more sane than OpenGL, for example. I haven't used Vulkan. I haven't used DirectX 12. And I haven't even, so on the Witness on the PS4, I didn't do hardly any of the PS4 specific stuff. So I didn't use the PS4's graphics API either. Someone's asking, do we have Lambda? Right now we have local procedures that can't reference things in outer scopes. And those can be anonymous, right? But they don't capture variables. So you would probably say something isn't a lambda or a closure unless it can capture variables from outer scopes, which we will do eventually, I think, because it's good to have that sometimes. I don't think it's as useful as functional language people try to make it out to be. They just get into this kind of like, if all you have is a hammer, everything looks like a nail kind of a mindset. And so they start using lambdas for everything, and then they think lambdas are important, when in reality they're not that important. But sometimes they are a really useful tool. We will make that work eventually. For now, if you declare a local procedure and you try to reference a variable from outer scope, instead of capturing it, it'll just say, you can't do that. That's an error. You can't do that. Now, in C++, for example, the way Lambda is implemented is just that it makes a scope, or it makes a struct containing the variables that you're capturing, right? And then it overloads operator parentheses, so you can call the struct like a function, etc. And then in later C++s like 11 and 15 and 17 or whatever, the compiler provides some syntactic sugar to make that nice. And that's probably similar to how we will do it, honestly. We don't quite have all the mechanisms for you to be able to program something that looks like a lambda on your own. Like, we don't overload operator parentheses yet, which we probably should. So that kind of stuff has to happen. And then it would make sense to build compiler support for it, probably. Have I read Man is the Measure? No, I have not. I don't know what that is. Have I considered preparing this language for scientific applications? I'm skipping most of the question because it's a long paragraph. I think there's a lot of overlap between game programming and HPC. I think so too, and I would like this language to be as effective as possible at stuff like high performance computing or embedded computing and stuff like that. Like all the areas where people still really care about performance and about being able to express things at a low level in order to maximize performance when they need to, but then to be able to do things at a very high level all the rest of the time in non-performance critical code so that you can get it done quickly and have a good amount of faith in the fact that that code is correct, right? So anyone who wants that as a mission statement, that's who this language is for. Now, I have a great deal of domain-specific experience in games and very little in places like HPC. So for now, I just have to sort of take it on faith, what's going to make sense. But I think that the things that are being done now make sense for all those domains, yeah. And then, later on what will happen is after we release the initial version of the language, we'll actually have some outside people using it, and we can see which features are working for who and which ones require modification and stuff like that. How's my German? I speak no German. How do I feel going from a warm region like California to a cold one like Seattle? Well, San Francisco, to be honest, is not the warmest place in California to begin with. It's sort of in the middle. I was born in Southern California, where it really is a lot sunnier and warmer all the time. It's kind of almost a desert in the places where I grew up. Not totally. Scrub brush desert. Yeah, it's colder here. How do I deal with burnout when I don't want to do anything? There are several times when I've given answers to that. I gave a whole talk about, for example, doing deep work and surviving burnout while you do that. And then at HandmadeCon this past few months ago, I gave some kind of an answer about that I'm hoping that I'm going to sit down with Casey at some point and do an elaboration video on. I need to bug him about that again because I think that I could lay out a really good answer for that. But yeah, maybe some people can paste some YouTube links for you. We don't really have time to go into that topic in the 10 minutes before the stream. It's a really big topic. How is it possible that The Witness is already almost a year old? I don't know, man. Time just flies. Hi, Albert H. How's it going? The first two talks, so someone's talking about the design of the language and what it is. The first two talks, actually, I don't necessarily recommend people to watch because they have ideas in them, but the ideas in them are not as good as what they started to be once I started really building it. And I think that's true for everything. Like once you start doing the real work, then you really see what's useful and what's needed. So there's stuff in those first two talks that I still haven't done because in retrospect it's not as important as the stuff that I've been doing for the past couple of years. So those first talks were really more about me psyching myself up to do it or something. So if people wanted an introduction to the language, I would say to start with the first demo, which was sort of the third talk, and go forward from there. Or, the first talk and second talk might give you some context about, why I and many other people are disgruntled with languages like C++ and stuff. But in terms of what the feature set and philosophy of this language is, I'd say they're a little incomplete at this point, and a little bit incorrect. Someone's asking, how are the types in the language made to be unique in the way that they are comparable by pointer? Is the syntax tree traversed several times in order to infer everything? Or is it some complicated stuff due to the dependency stuff? That seems like two different questions. For how are types in the language made to be unique? Each one just has a serial number. It's just like an index, right? And I believe at runtime, I actually switch out. You can go look at the appropriate demo, but you know, if you're in embedded computing mode where you don't want extra data stored around in your program, then we don't pass type information for all your types, right? Or we don't compile that into your executable. And in that case, you get a number for each type. But if you have type info for everything, then you get a pointer to that type info. And you know, type infos are of non-zero size. So 2 pointers are going to point to different addresses. And then when you ask, are these pointers equal, it's just a numeric equality comparison. So the second question, is the syntax tree traversed several times in order to infer everything, or is it some complicated stuff due to the dependency stuff? It is some complicated stuff due to the dependency stuff. Basically, every top-level declaration, and sometimes some non-top-level things, is an individual item in some queue of things that we're trying to figure out the types of, for example. And we run through every expression in that thing. So if it's a procedure, we start running through every sub-expression in the procedure. And if we hit something that we can't find the type of, so for example, you might find an identifier, and that identifier might not be done resolving its type yet. So if you want if you want 1 plus x, then the type of that might be float if x is a float, or int if x is an integer, or something different if x is like a struct with an overloaded operator, right? So you can't know the type of 1 plus x till you know the type of x. If x isn't done yet, then that inference of that procedure just sort of yields for a while, and it says, okay, I yielded on x. I'm like right here in my attempt at making my way through this thing. So there's a bunch of things, and they yield to each other when necessary, but it's not using threads or fibers, because I think that's bananas. It's just straight up data structures. There are threads in the compiler to parallelize things, but they're at a more outer level than that. I demoed the threads a while back. Someone's asking off topic, would you recommend using a commercial engine like UE4 for a sort of beginner for a smaller game? Or is it worth it writing my own engine and work my way up programming skill-wise, if own engine, OpenGL, or DX? Well, what do you want to do? What do you like more? If what you want to do is skilled technical work and you care less about the actual game, then write your own engine. If what you want to do is make a specific game and you want the game to be good and you're a beginner, then probably use someone else's engine in the beginning, right? Because it'll get you going faster. It'll get you to understand what making a game is like. Eventually, I recommend everybody have the capability to build their own engine. And then they can decide for any particular project, should we build our own or should we use this engine? And they can look at the trade-offs of that, right? But you want to at least have the power to make that decision. And until you have the power to make that decision, then you're a little bit powerless as a developer, right? So, but if you're a beginner, you know, you're in the beginning times, and so that kind of thing is not so important. In the beginner, what you really want to do is just ramp up and get good at things. And so, do you want to get good at designing and deploying a game first, or do you want to get good at programming first? If you want to get good at programming first, build an engine. If you want to get good at designing and deploying a game and dealing with all the assembly of different complicated things that we try to put together in order to ship something successfully, then use an engine to start and build your own stuff later. And in fact, you can, if you start with something like Unity or Unreal, you can learn how to build your own stuff by building components for those things and then gradually increasing the scope of what you build. At some point, you get to this awkward point where you're adding so much that you feel like you should junk the engine you're using, but you can't really. That's a hard point, but until you get to there, you can increase the scope of what you build. Someone's asking about implicit context determining which custom allocator to use. Does that mean it's never safe to delete a pointer outside of the scope where you allocated it? It seems like you could get into trouble using a different proc for allocation versus deallocation. See, that's not really any different than programming ever, right? So if you're using some API and it allocates some resource for you, then you have to deallocate that resource according to the way in which it was allocated by that API. You don't know if it used malloc. You don't know if it's got its own heap or whatever, unless it documents that. Sometimes people will document it and say, oh, this is allocated with free, and you can just free it or whatever, right? So what you're really talking about is just the usual thing that happens when you're manually managing memory or any kind of resource allocation and deallocation. You have to know where things came from, and so that's no different with the implicit context thing. Now, if you look back in some of the earlier demos, then for ease of use, I will often make data structures store which allocator they use. Well, and that's not even just for ease of use. It's just, so for example, say I make a hash table. When I construct the hash table, I could either explicitly set an allocator on it, right? Or it'll get the allocator from context, right? And so if it gets the allocator from context, I believe the first time I allocate, I actually store that allocator so that later, I can make sure I use the same one. So that's an ease of use thing, but you pay for that by storing an extra procedure pointer, right? Which you might care about if you store a million zillion hash tables. So it's all, there's just trade-offs. There's always, and this is what, so part of the fact that you have to think about this stuff is why so many people are like, oh, languages should have garbage collection because programmers shouldn't have to think about that. And, I'm a little bit sympathetic to that idea, but you pay so badly in performance. Nobody ever wants to admit how badly you pay in performance for that, but it's so bad that I doubt I will ever use one of those languages for anything real that I want to ship to people. That's an extreme statement, but certainly not an engine-like thing. So, it's just part of your job as a programmer when you're manually handling memory is to know where that memory came from and where it's going to go when you need to get rid of it. And the context stuff, if you're trying to use that in order to sweep that stuff under the rug so you don't have to think about it at all, that's a mistake because you'll end up making bugs, right? What the context stuff is for is to make it easier, right? Or to let you, for example, use somebody's library, and every time you use that library, you can swap out the allocator to control that library's allocation, right? Without the library having to have lots of weird hooks for letting you insert an allocator, like the language supports that. That's what it's for, but you're still supposed to know that when you use that library, you're using a certain allocator, right? Anyway, so that's going to be it for Q&A. We might do a little more after the stream.